Let's see here. Learning target. I can show a quadrilateral is a parallelogram. So we're going to be talking about parallelograms today and kind of like proving them. So you'll see right here, we've got 5 different ways that you can prove that a quadrilateral, which again is a 4-sided figure, is a parallelogram. So show that both pairs of opposite sides are parallel. And again, we can see that those 2 sides are parallel because of those triangles, and these 2 sides are parallel because of those 2. Show both pairs of opposite sides are congruent. So again, these congruence lines tell me that these 2 lines are the exact same size. Show that opposite angles are congruent. Again, congruent means the same word or the exact same. And so this has 1 arc, this has 1 arc, so those 2 angles are the same. This one has 2 arcs, this one has 2 arcs, therefore those 2 are the same. Show 1 pair of opposite sides are congruent and parallel. So again, we're kind of combining the 2 where, hey, we've got this congruent one and we have this parallel. Then by definition, these will also have to be congruent and these would also have to be parallel. So there's no other way that these 2 sets of lines could be congruent and parallel if the other 2 sets weren't congruent and parallel. And again, show the diagonals bisect. Again, bisect means cut in half of each other. And so we can see this line is equal to this line, and this line is equal to this line. The diagonals are created by going from the vertex to the opposite vertex. So you can't go to an adjacent vertex, you have to go opposite. Are the children on the ride parallel to the ground? Explain. So we've got the kids up here on line AB. I see that the roller coaster or whatever ride thing it is 38 feet. I also see that the distance from A to D is 16 feet. And then right here, I've got 38 feet again. So if I look up here and I say, hey, this is basically rule number 2 here. Show both pairs of opposite, and again, opposite means like across. Show both pairs of opposite sides are congruent. So 16, so we can just say line AD is congruent to line BC. And then line AD, or AB, excuse me, is congruent to line DC. So yes, it is going to, I guess that doesn't answer the whole question. So that tells us that they're parallelogram. Now we have to decide if it's parallel to the ground. And we see that, hey, this line is parallel to this line here. So the line on the bottom, line L, you can see that's what it's called, line L, is parallel to line DC, which is true. And then again, because we know it's a parallelogram, the properties of a parallelogram state that the 2 sides are parallel. So this line is also going to be parallel to line L and line DC because it's parallelogram. So our answer is yes. And again, this would be our explanation right here. We're explaining with our math. This is how we prove, because AD is congruent to BC, AB is congruent to DC, and then therefore line L is parallel to line DC, and line AB is parallel to those because it's a parallelogram. The doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know that SV is equal to TU. So again, one way that's good to explain is just cause and effect, or a statement. So I'm going to call it a statement. And then like it's going to be like my proof or my rules, my why. So I'm going to say, and again, what do I notice? I notice these things here, and I notice these things here. So if I look, okay, I've got parallel and I've got congruent. So I'm going to say ST is congruent to VU, and that's given to me in the picture. And then I know that ST is parallel, 2 lines in a row, it means parallel to VU. And again, that's given to me. My V's and U's look identical. And then if we look up here, we could say that theorem 8.9, number 4, show one pair of opposite sides are congruent and parallel. So then we could say that this is a parallelogram. We just proved that. So, and properties of parallelograms tell us that SV, all opposite sides are going to equal each other. So I don't know if we wanted to say SV is equal to TU by the definition of a parallelogram. For what value of X is quadrilateral CDEF a parallelogram? So this is like what we talked about here. The diagonals bisect. Bisect means cuts in half. So if it cuts it in half, I know that these 2 lines are going to be equal to each other. So 5x minus 8 equals 3x. Negative 8 equals negative 2x divided by 2. Therefore, x equals positive 4. So if x is any other number, it's not a parallelogram. It's only a parallelogram if x equals 4. All right, so let's plot these points. Let's see here. Negative 3, 3. 5, 7. 8, 4. Oh, wait. 1, 2, 3, 4, 5, 6, 7, 8. And 0, 0. So let's connect the dots here. Ooh, that one didn't work. Redo that one. Okay, close enough. So as what we got to do is we got to count. Okay, so if these lines are going to be equal, I got to figure out what are these distances. Let's see if I can move it. We're going to redo that. That's bothering me. So what I'm going to actually do is I'm going to create triangles because I got to figure out this length. So I'm going to draw in a triangle right here and figure out what my base, what my height, and then how can I figure out X, because that's what I want to know. So if I draw this out here, that's what we're trying to figure out. If we count 1, 2, 3, we have a height of 3, and 1, 2, 3. So again, to find it, we do a squared plus b squared equals c squared. 9 plus 9 equals c squared. So c squared equals 18. But we don't want c squared. We want c. So we need the square root of 18. So let's go ahead and double check. Did we get the same thing over here? 1, 2, 3. 1, 2, 3. Yep, so I know that this is also the square root of 18. So there's a lot of those different theorems that we could use. Maybe let's just look and say, hey, let's figure out, we're going to use the fourth one here where we show that they are parallel and congruent. It's good to review. So again, if we think about this, my rise over my run, if I'm starting right here, my rise is 1, 2, 3. My run is to the left, 3. So 3 over negative 3 is negative 1. So this is a slope of negative 1. Let's see what our slope is over here. Starting right here, again, 1, 2, 3. I move to the left 3. So I get a slope of 3 over negative 3, which is negative 1. So these lines are parallel and these lines are congruent, which means, yes, we have a parallelogram. And I don't know, let's see here. If you wanted to call it by theorem 8.9. Yes, theorem 8.9.